Hello, and welcome to the EvillGenius Show, Kubernetes on Azure Best Practice Series, episode number 2. I'm your host, Eddie Villalba, aka EvillGenius, and I'm a senior cloud architect for Microsoft, working with enterprise customers, helping to deliver solutions, cloud-native solutions on Azure using open source technologies, specifically around containers and Kubernetes, and AKS is our solution around Kubernetes. Kind of what I'm going to put forward today are just some suggestions, best practices, completely my own opinion, even though I am an employee of Microsoft. My suggestions that I put forward on this video series are my own, and I have other colleagues and members of the community that have their own opinions and put together their own suggestions, and I think they're all valid. So this is just my point of view from working with very large enterprise customers and solutions that have worked for them. Today, we're going to continue our journey down best practices, starting from kind of like I started from the network up. And if you didn't see episode 1, that's okay. Don't worry about it. You don't need all the concepts from episode 1 to understand this. We just covered basic networking. In this episode, we're going to focus on ingress and egress patterns in Azure and AKS. Kind of move forward through some of the concepts. I put together, again, a quick little slideshow that I'm going to talk about, but I want to get through it very quickly because they're mostly default Kubernetes concepts. And then I want to move directly into a cluster and start showing you how it actually works in real life. So to catch up, in case you haven't seen any of my episodes or you're new to the Azure world and don't know what AKS is, this slide here is just kind of what is AKS, right? It's a managed control plane offering from Azure. We host Kubernetes. It is upstream Kubernetes. It's not a Microsoft fork Kubernetes. Today, I think 1.12 patch version 0.6 for us is the latest version that you can push out on AKS, and that will be coming out. If you want to know our changelog as we release new feature sets, definitely go to github.com/Azure/AKS. And under releases, you'll see all of our releases there of new features and new capabilities that we're adding to the platform. So again, just wanted to show you a little bit of an overview of what AKS, managed control plane. You have access to the API, everything else that kind of looks and smells and everything tastes just like Kubernetes because it is Kubernetes. The nodes, however, actually sit in a virtual network in Azure, and they sit in an Azure subscription that you have, and you can see things happening, as we'll see in a second. So today I wanted to talk about ingress and egress. And to understand ingress and egress in Kubernetes, we have to understand the different types of services that you can, as part of the services object and the API built into Kubernetes, you have to understand what options there are for types of services. And there are more than 3, there's 4 actually, but I just wanted to kind of highlight these 3 because these are typically how services access other services or talk to a service. The default is cluster IP, node port is another option, and then load balancer, which is an option in the cloud provider. So to dig down a little bit on cluster IP, what is it? Basically, it's the default option. It is what is used to talk to a service within clusters. So think of it as intra-cluster private communication. It's a durable IP address and port that's assigned to a service that then fronts the backing deployment of pods that those IPs can come and go, right? They use the endpoint API to determine what the IPs of the backend services are. And then kubectl, when you create the service, does the IP tables, or in the case of newer on-premise clusters, or you're deploying some more experimental stuff, IPVS will take care of writing all of the rules around the networking for that. Node port is typically used to expose a service to an outside the cluster, and it's typically used in on-premise deployments or custom deployments where you want to put a load balancer in the front, something like an F5 or Palo Alto or Cisco, and you decide you want to control the load balancing process. And basically it maps a high-level port on each node, somewhere between 30,000 and 32,000, to the port that you're exposing as the node port to the port that you're exposing on the pods as the backend service. And this allows you to kind of make sure there's no port overlap. If you don't specify a port number, Kubernetes will automatically assign a port number to that node port. So that's That's another typical type. Sometimes also people do host ports, which is where you're actually just kind of giving you're passing it down right to the host. So I'm not going to talk about that. That's not for this this session real quick. The next type of service is the most common in cloud providers, which is what we call the load balancer service. And as you can see in the little bit of snippet of YAML there, load balancer type, it only really works in cloud providers. But the cool thing is every cloud provider understands when they see that it needs to do something, and we call the cloud provider API. In this case, in Azure, we create an Azure load balancer, and that Azure load balancer is created for you through API calls from Kubernetes. Now, the default action for AKS is that when you declare a service with load balancer type, you will get a Azure load balancer basic. So there's two types of load balancers in Azure, basic and standard. You get a basic load balancer, which is free of charge, and you get a front-end public IP address for each service that you expose with that load balancer type. So that's a key thing. If I have a bunch of services I want to expose outside my cluster, and I just use load balancer as my type, it will create a front-end IP address, a public IP address on that Azure load balancer for each one. So just be aware of that. You might have like 5 or 6 IP addresses, public IP addresses on your Azure load balancer. There is a way to ask for an internal load balancer, and we'll talk about that in a second when I show you the YAML files. But basically, we use an annotation in our YAML file to basically tell Kubernetes, hey, or more importantly, tell Azure, hey, yes, I need a load balancer, but I want an internal load balancer. I don't want a public IP address. And that's normally used in enterprises where they have some type of hybrid connection back to their corporate center. The other thing that we see in combination with that is using an ingress controller. So your ingress controller is kind of running inside of Kubernetes, and you have a bunch of different flavors. You have Traefik, you have Contour from Heptio. I don't know if the VMware acquisition is going to change the name, but that's what it's called right now. You have Nginx, obviously, HA Proxy, and there's a bunch more little ones here and there. Nginx probably being the most common out there that I see. But Traefik is catching up. It's actually a pretty good little enterprise level ingress controller. Sorry. So with an ingress controller, you still have to expose the front of that ingress controller, because at the end of the day, the ingress controller is a service. It's Nginx pods running in your cluster, and they have to have a service endpoint, and that service endpoint has to be exposed either to an internal load balancer at Azure or an external load balancer in Azure, and we'll see that in practice. And this is typically how you want it, because this is layer 7, right? Everything that I showed, the load balancer concept, which is what I showed you here, is all layer 4. It's really, really dumb, right? Where this gives you layer 7, which you can do SSL termination, you can do host-based routing and path-based routing, SNI, API kind of commands. Anything you can do with Nginx or one of those other proxies, you can pretty much do here at this level. So it's a nice little extra service to have, but it's still in combination with a load balancer, either internal or external load balancer. So what about in Azure? What other options do I have in Azure? And I kind of put these together in what I call easy, medium, and hard or complex type solutions, right? And when I say easy, the reason I say easy is because it's maybe 2 or 3 clicks, or in some cases completely automated. So Azure Load Balancer with public IP, this is basically what we call an ALB in Azure. It's easy. It's right from YAML. So it's a layer 4 load balancer only. An ALB plus an ingress controller running in AKS is also relatively easy, and they combine a layer 4 load balancer with a layer 7 proxy. So there you get a little bit more power. And they're really easy to set up, and we'll show you that in a second. When I go into this medium section, these are additional services that run in Azure, networking services like our Azure Firewall, our application gateway service, that allows you to add layers of security and layers of application awareness into your platform, right? And the Azure Firewall, it's a great service. We have threat modeling detection built in. It's a highly available firewall service. It's great. And we'll show you an example. I'm going to actually highlight this one here, which I think is the most elegant, right? Using Azure Firewall as a service to front end your traffic, you get a public IP through Azure that's a single, you can whitelist with other third parties if you need to. You get a Azure ILB to come in to get incoming traffic, layer 4 load balancing to go to your Nginx ingress controllers, and then you use your ingress controller of your choice inside of Kubernetes to do all of your layer 7 proxying, host path routing, SNI, all that stuff is done at the ingress controller level. There are combinations of others, so application gateway with an ILB, that's also, I'd say medium. There's not yet an easy way to do that in an automated fashion. You have to build it. So using Terraform or Ansible or Azure JSON templates, you can build those out relatively easy, but it's not automated in the sense that I have to do things when I expose a service. I have to write rules, or I have to do things on one of the other services, or figure out a way to automate it using alerting, Azure Functions, custom code, a container that watches things, whatever. You're going to have to automate it because it's not built into the system just yet. And then we have the really complex, and this is as you layer more services, right? Azure Firewall in front of an app gateway, in front of an ILB, in front of AKS, then things get more complicated. There's more pieces that have to be tied together correctly, and if you don't tie them correctly, you could have potentially an issue. And then things like third-party network virtual appliances. So in Azure, we can host things like F5, Cisco, Palo Altos, Barracudas, and putting those in front, you then bring in a third party. All of them work a little bit differently. So you want to make sure that you've tested all that and you understand how it works, and you have some kind of tracing from front to back, so that as you're troubleshooting, if you have an issue with an application running in AKS, that you can work with support to make sure that they understand your traffic pattern all the way from front to back, right? And so I would consider those highly complex or more complex, right? Now, what I want to show you is the basic one. So the first thing I'm going to do is kind of go over here to my cluster. And this is just let me clear this out. This is just a very vanilla cluster. So you can see I'm going to do kube-get all, right? And you can see there's pretty much only the Kubernetes service running in this cluster. If I say get nodes, you can see I'm running a 3-node pool, and I'm currently on version 1.12.4. I just haven't upgraded it yet, but I will. So I'm going to go ahead and deploy a simple service. And here I have 2 services. This first one is just a basic service. It's using the Kubernetes up and running container from the great book, Kubernetes Up and Running. So here it is. So great book, Kelsey Hightower, Brennan Burns, and Joe Beta helped me get through my certification exam as well. So if you get a chance, definitely pick it up and read it. But anyway, this is a basic template file, nothing complex at all. And you can see where here I have type load balancer. And that is going to make sure to expose port 80 on the front end of the load balancer and target port 8080 on the service, which is what the container port is here. And I have 2 replicas to be exposed, right? So we're just gonna go ahead and apply that file. And you'll see, we'll do external first. All right. One of the things I want to show you before I hit OK on this, I want to show you basically what it looks like in Azure. Okay. So if I go here to Azure and I go to my resource group, this is the resource group that has the IaaS components of my AKS cluster. So there's a resource group that deployed the AKS service to, and then it creates a managed resource group that you shouldn't really touch. It's there, it's visible, but you should just leave it alone. Okay. So what I'm showing you here is basically these are default services that are deployed in a resource group when you deploy an AKS cluster. And you can see here, my virtual network happens to be in it. I chose basic when I deployed this. And you also notice that there's a network security group, and a network security group is just a basic NSG, nothing special about it. It's the default NSG. So it might as well be empty, but it's a default NSG. So when I click on this service here, or when I deploy this service, it's going to go ahead and we'll go ahead and get all again and see what we have. So it deployed basically my 2 pods, and it deployed a service. And you'll notice that it has external IP in a pending state. So what's happening right now, if I come over here to this side and I hit refresh, you'll notice that on refresh, a load balancer and a public IP address were created. So basically what's happening now is the API was called, the Azure API was called, Kubernetes, we created a load balancer, an Azure load balancer with a front end IP that we assigned to the front end IP configuration of this load balancer. We created the backend pool of your nodes. We created health probes as well to make sure that if a node is not ready or not available, the TCP would fail and it would take that node off of the load balancing pool. And then we have our load balancing rule for the traffic that we want to hit, port 80 in this case, right? The other thing that is happening is behind the scenes, at some point, this network security group is going to get updated as well with the proper inbound security rule to make sure that I'm only opening up inbound the port that's necessary that I've exposed through my service when I called it, right? So we're going to let that happen for a little bit. We'll let it watch as I move forward to the other demonstration, which is now an internal load balancer. And the YAML file for that looks exactly the same. I haven't changed anything but the app labels and the name, the metadata name information. But what is different is I've added this annotation here, right? And this annotation basically tells the Azure cloud provider, I want an internal load balancer. So now you notice that I have here my NSG came in, it's allowing port 80 TCP from the internet to the public IP address of the front end of that load balancer. And if I go and do get all again, you should see that now the service has a declared external IP. And if I hit that IP address from a browser, this is from a demo I was doing earlier. There you go. Yeah, you'll see in a minute this will change, and now I'm hitting this pod here, right? So R99MJ, R99MJ, perfect. And we don't do like round robin load balancing. We actually do a hash-based load balancing. So you may see that you're getting the same pod on the back end quite often, and that's okay. You know, if a pod goes down, we'll still move it over, so on and so forth. So it's not true round robin, just to be aware of that. Okay, so now let's go back to our internal deployment. So we're going to go ahead and deploy an internal. So again, I'm just going to change this to INT. And now we have our internal created, and we'll get all again. And you'll see here, now I have my QAR service internal. I have a cluster IP, which is on the service for internal communication. But you'll also notice I have this external IP is in pending state. Now let's go back to the Azure resource group and let's look at what's being built now. So if I refresh, so keep an eye down here, if I refresh, now I have a new load balancer called Kubernetes internal. And that means I know I can see visually that it's an internal load balancer. The front end IP address is a private IP on the subnet that the cluster nodes are on. And that's adjustable, by the way, with an annotation, which I'll show you in a minute. But now, if I go back here, get all, in a minute, you'll see that this pops up and I will get the front end IP address of that load balancer for my service, right? So the beauty here is this is just Kubernetes YAML files. You don't have to do anything else, right? It's not very complex at all. If we take that and we extrapolate further and we go back to this option, your ingress controller, the thing here is you just determine how you want your ingress controller service to be exposed. The nice thing with Nginx, you can build into Nginx the values file for the Helm chart, a descriptor to add exactly what you want. So here's my values file for my Helm chart for Nginx. And you'll notice I add under the service stanza, I add two annotations. One is that I want it to be an internal load balancer. And two is I want to dictate exactly what subnet to put that load balancer on. So that's what I was telling you earlier. Tech, by default, it'll put the front end IP of an internal load balancer on the same subnet as the nodes. But in this case, I want to pick a different subnet in my larger virtual network, and I could do that here, right? So very easy to do. If I wanted this to be an external facing Nginx service, I would just have to take off this internal true and internal subnet, remove those two, and by default, it's automatic. The service is type load balancer right there, line 191. So it'll automatically create my external load balancer for me. So very easy to get up and running with either a straight service exposed or an Nginx service exposed, and then you just have to create an ingress rule for your services behind Nginx, right? But we take care of everything else, right? So as you see here, here's my internal service endpoint, and now here is my external service endpoint, all right? Now I want to show you a little bit more complicated setup. And this is really kind of just something I've been playing around with for a customer that was asking how to do this. And I kind of templatized it for him a little bit. And this is kind of the drawing I put together as a sample of an environment that met the requirements that they had. So first of all, I have inbound and I have an egress and an egress kind of path. So the orange is the ingress path and the red is the egress path. So in this environment, what they wanted is the Azure Firewall service fronting all traffic coming into their AKS. And they wanted also that any traffic leaving AKS had to be forced to the firewall. So that's the egress route, right? So the first thing we'll look at is ingress. Ingress, I do an HTTP request or HTTPS request to a URL, to a DNS name that's mapped to an IP address that is the front end IP of the Azure Firewall. And once it hits the Azure Firewall, I have to create application rules, or I would actually DNAT rules, destination NAT rules, that will say, hey, I have a DNAT rule that says any traffic from this public IP, on this public IP to this internal IP, I want you to translate it for this port to that port. And then I want to allow it to go from from whatever source. So I can control that DNAT rule, and it inspects the DNAT rule. Once it inspects the DNAT rule, it then forwards it to the proper rule based on priority. So in this case, it will forward to the internal IP address of the internal load balancer. So in the case like this one here, where I had 10.240.0.7, it would say send over to 10.240.0.7. Then the internal load balancer does this hashing algorithm because I've exposed an Nginx ingress controller using internal load balancer. So it has a load balancing rule, and it will determine using its hash-based layer 4 load balancing to send it to one of the two Nginx ingress controllers in my deployment. Because when I deployed the Nginx Helm chart, I asked for 2 replicas. It's somewhere in here, but I asked for 2 replicas, right? So that way I have kind of like an HA, there you go, replica count equals 2. I have an HA type configuration for my cluster. Now, Nginx does its layer 7 stuff. So if there's SSL and the host path is based on an SSL based host, boom, it'll do the TLS lookup. I'm using Let's Encrypt and cert manager with Let's Encrypt to take care of that for me. And then it will take care of passing it to the correct path based upon the URL or the host and header that was brought into the call. So that is ingress, right? So now I have firewall with intelligent threat detection. I have load balancing to my ingress controllers, and I have layer 7 at my ingress controller. Really, really sweet. Then on the egress side, and I use the example of cert manager, because cert manager has to talk to a certain Let's Encrypt URL to get and verify my certificate and then create the cert for me. So I had to make sure and create an outbound or an application rule for an FQDN to make sure that it can happen. So I have this pod called cert manager running. And what happens is when it does its request to, https://staging.api.let'sencrypt.org, it will then hit the wire, the Azure network. But we have what we call a user-defined route. A UDR is basically a route table, and it overrides any other routes that are kind of built into Azure or learned routes through BGP. And this one I'm saying it's catch-all. Every piece of traffic, 0000-0, hit my wire, always forward to the Azure Firewall internal IP. Therefore, it gets pushed over to the firewall. The firewall then does the inspection, verifies that there's an application rule allowing that traffic outbound on that port and to that destination. And then it goes ahead and allows it to go Let's Encrypt. So let's see how that works. Let's move over to another cluster that I have. And let's see here. Okay, so I have a cluster here, and in that cluster, I have some services already running. This up here. So as you can see, I have two Hello World services. One's called Alert Toucan, one's called Krabby Raccoon. They both have just a different some wording that's different, that's all. And then I have two services. This AKS Hello World service is pointing to one of the pods, and the Ingress demo is pointing to the other service, right? You'll notice that they're only on cluster IP, so they're only internal services. And I also have Nginx. Nginx is running in kube system, however. So we'll just say get all, or actually we'll just do get deploy and -n, we'll do kube-system. Okay, so I have, you'll notice I have here, I have cert manager and the webhook, so it automatically does the cert, TLS cert upon issuance of a Ingress rule. I have also my Ingress controller and my default backend, right? So those are the two things I kind of added into kube system. Maybe not best practices, but I just did it that way. So with my Ingress controller, the other thing I have, if we look here in Azure, is in that resource group. Let's go back to resource groups and oops. Let's go up here, we go to this one. You'll notice I have my Azure Firewall service here, and I have my route table. That route table, I told you, is my catch-all, so 0000/0 goes to 172.20.216.4. That is the internal IP address of that Azure Firewall. So if I go to Azure Firewall, click here, you'll see it has private IP address, and it also has an owned public IP. So it's a public IP that it's assigned to, which is that 52.230.219.36. And I've also added a DNS name to it for ease of use. So this is kind of nice that you can add that. It doesn't default it when you create a public IP, but you can add it to any public IP. The other part of this firewall that's really cool is, like I said, I can turn on threat intelligence, and I can also do all of my rules. My rules here is where, under NAT rule is where my DNAT rules are located, right? So that's kind of like my inbound rules and what am I doing. I can do DNAT, and I can also do source NAT rule types actions. Under network rule, these are where I have things like domain names that I need to allow outbound. And basically in this example, or not domains, but protocols. So in this example here, I have 22 and 443. This is required for the master control plane to talk to our nodes. So I have source address and destination address allow. Now, this is going to get better. We're going to start using service tags and stuff like that. That's coming down the line. But for right now, I'm using source address and destination address, or kind of anywhere. The other rule that I have here is application rules. Now, this application rule is more about FQDN type allows and things of that nature. So in this example here, I have what we call the basics, and this is what I have here is allow from anywhere on port 80 and 443. So I'm allowing to go out from inside these URLs, and it's basically just wildcard URLs used for Docker registry and the master control plane. So I call this like the basics. You have to have these today open. Extended adds things like Azure Container Registry, Ubuntu.com, and OpenSUSE for patching the underlying operating systems, and Azure Blob for blob storage. Just an example. But again, it's all port 80 and port 443. So I can dictate the port. The other rule I added was the one rule that I told you about for Let's Encrypt, for that egress. So in this example, I say, hey, let anything api.let'sencrypt.org on port 80 or 443 allow that traffic, right? So it is allowing that traffic from anywhere, okay? And to this target. So in any source inside my network to the target FQDNs. So now with this setup done, this allows my application, my application, again, ingress and egress, to come through the Azure Firewall. And then once it hits the Azure Firewall, it then goes to my ingress rule, my ingress controller. And here is where I put in this ingress rule. And this ingress rule just basically says, look for Nginx ingress class. We're going to use the Let's Encrypt staging cluster issuer and rewrite all targets with a slash for default path, and if they don't put it. And then finally, I add, for this host, I use this TLS secret to do HTTPS communication. And then I have a path-based routing to my 2 different services. And when I hit that, what I should get is on this URL, without anything after the host, I get welcome to Azure Kubernetes Service, and it's just a basic, the logo. And you notice it does say not secure, and that's because, again, I'm using the staging certificate for this service, right? If I add the slash hello world 2, which is outlined here in this path, you'll notice it goes to my other service. It says AKS Ingress demo. So there's the 2 services. So now I've gotten the best of everything. I've got a firewall that does all my logging and monitoring, and I can do threat modeling and threat net assessment, and I can alert and deny, kind of automatic if I want to. And I can then also do path-based routing and SSL termination within the cluster for my services. And I can split up all my services using Nginx. And then in the middle is just an Azure internal load balancer that takes care of the moving it across my highly available Nginx ingress service. Right? So again, this is more of just a sample, not production ready type environment. It does take a little bit of configuration, so I did a lot of this in kind of like a shell script because today you have to do a few things. I will share this on my Medium blog post, a link to my GitHub repo. So it's the same GitHub repo for my first video. I'm just adding new episodes and the content for those episodes as soon as I clean this up and remove anything that's like secrets for my deployment. By the way, give full credit to one of my peers, a global black belt in Europe, Dennis Zielke, who did an awesome write-up on his Medium blog post on how to configure the Azure Firewall service with AKS. In this one, I just took all of his stuff, tweaked it a little bit for my deployment, added more variability to it, and then made sure I added the rules for Nginx for Let's Encrypt for Cert Manager, and Let's Encrypt to be able to get certificates. But otherwise, he did all the heavy legwork and figured out how to get the Azure Firewall to work correctly. So I'll give a link on my show notes for Dennis's Medium post as well, and please follow him. He's an awesome guy. So anyway, just want to wrap up. Again, showed you kind of 2 default deployments using either just a regular Azure load balancer, so you have expose your service. We talked about an internal load balancer versus external load balancer in Azure. We talked about adding an ingress controller, fronting it with an internal load balancer, and then looking at other services like the Azure Firewall service, the Azure Application Gateway. We have a lot of other cool services coming out. There's another one called Azure Front Door, which kind of combines the firewall and app gateway kind of all in one. I did play around with that a little bit, and hopefully I can get a sample architecture together to put that in place in front of an AKS cluster and kind of get that working. But there's lots of different services, and I know the teams are working really hard at integrating these even easier for it to be even easier to deploy these. So hopefully at some point all of these kind of fall into the easy column, and you just say, hey, I want this and I want this, and it'll automatically deploy those things for you and wire them up correctly. So that's the hard work the team at the Azure Compute team and the AKS team does every day. Thank you so much for watching. I hope you got something out of it. I tried to keep it as short as possible, but I know it's a very complex topic. Hopefully next time, our next video, I should have a little bit more information on cool best practices. And I think I'm going to focus a little bit on persistent volume. I get a lot of questions on how do I persist my data? Can I do databases in Kubernetes and AKS? And what are my best options? And we'll talk about what those options are for persistent volumes in AKS. Meanwhile, please, in my show notes, if you have any comments, suggestions for new episodes, things you want to get clarified for best practices, please let me know on my Medium blog. Clap if you like this series, if you want me to continue. or on the YouTube show notes. If you're watching this through YouTube, please add it, your comments there, and I do watch them and do listen to them. And hopefully we'll add more of these as we go along. And I'm also looking to bring in some guest speakers and presenters, so we can do more of the dialogue, and that'd be really cool. So I'm working with a friend of mine that he's been doing a lot of AKS in the field, and I'm going to bring him in as well to do a session with me. So I think that would be kind of cool. Until next time, keep watching all of our shows. Look at the Azure blog for new updates. Look at the AKS update page on the Azure website for any new releases and new things that are coming out in AKS. And have a good one. Keep on learning.